Hi students. So in this lecture, we are going to solve some more questions in simple harmonic motion. Let us see now question number 6. Two particles executing simple harmonic motion along x-axis and their position coordinates are given by x1 equal to a cos omega t, x2 equal to a cos omega t plus 2 pi by 3. Find the maximum separation between them. So this is a question given, and you can see from the given equations x1 a cos omega t and x2 a cos omega t plus 2 pi by 3. So from this we can say for both these two particles mean position is x equal to 0. I am writing here. So first thing what we can do is mean position is the same. Right. We can take that as x equal to 0. That is mean position. So find maximum separation. So what we can do is here. First of all, we can find x1 minus x2, difference of their coordinates. If we can find difference of their coordinates as a function of time, then we can get what is maximum separation. Let us see here what we are doing. x1 minus x2. x1 minus x2. It is a cos omega t minus, I am writing here. So it is cos A minus cos B, right, in that form. Means if you are not knowing that, I am writing here cos A cos A minus cos B equal to minus 2 sin A plus B by 2 sin A minus B by 2. Now use that here. So minus 2A sin sum of this omega t plus 2 pi by 3. Sum of those two by 2. So omega t plus pi by 3. Next, sine of A minus B. Here A means omega t, B means omega t plus 2 pi by 3. Right? Then see what we are getting here. So we are getting here sine minus pi by 3. So writing this as 2A sine pi by 3 into sine omega t plus pi by 3. So from this we can say x1 minus x2. That is now separation. That separation is maximum if sine of omega t plus pi by 3 is 1. Means when that value is maximum, then x1 minus x2 becomes maximum. And that maximum value, how much here? You can see here that maximum value is now 2a sine pi by 3. That is root 3a. Right? That means once we get this expression x1 minus x2 as a function of time, so we can get separation at any point of time. I am repeating. If we get x1 minus x2 like here as a function of time, then we can find separation at any point of time. Right? So this is method 1. Okay. Right. Let us discuss now method 2. So earlier we have learned in maxima and minima. So whenever a quantity becomes maximum or it is a minimum, then its first derivative becomes zero, right? So here separation should be maximum. So separation maximum means x1 minus x2, derivative of that should be zero. I am writing that here. Separation is x1 minus x2. So it should be maximum. Therefore, d by dt of x1 minus x2 should be 0 because x1 minus x2 should be maximum. Now derivative of x1 with respect to time, that is giving us velocity. So that is v1 minus v2 equal to 0. That means v1 equal to v2. So when separation between them is maximum, if their velocities are same, separation is maximum if their velocities are same. Okay. So we are equating here velocities v1 equal to v2. Okay. Now see derivative of x1. It is minus a omega sine omega t. Okay. And derivative of x2 minus a omega sine of omega t plus 2 pi by 3. So both sides I have cancelled minus a omega. Remaining is now sine omega t is equal to sine omega t plus pi by 3. But see here, this is omega t. This is omega t plus pi by 3. That's why I have taken here in the place of omega t, pi minus omega t. So why we have taken pi minus omega t means in second quadrant, sine is a positive. So sine omega t is equal to sine pi minus omega t, right? So now equate pi minus omega t is equal to omega t plus pi by 3. So from this, omega t equal to pi by 6. Now substitute this value in x1 and x2. Substitute this value in x1 and x2, right? Then x1 value root 3 by 2a, x2 value minus root 3 by 2a. So students see carefully here. We got x1 positive and x2 negative. That means x1 is right of the mean position. I am drawing here. See carefully. This is mean position. X1, that is root 3 by 2a positive. Right of mean position. X2. X2. X2 is now left off. So it is a minus root 3 by 2a. So separation between them, that means we have to consider root 3 by 2a plus root 3 by 2a. That's why I have written here x1 plus mod x2 because x1, x2 they are only coordinates. Getting the point? So separation is equal to maximum separation is equal to x1 plus mod x2, that is root 3. So like this we can solve in both the methods. So method 1, finding separation as a function of time. Method 2, whenever separation becomes maximum or separation minimum or separation constant, their velocities must be same, right? Because rate of change of separation should become 0. Okay. So we are equating here velocities and from that getting the answer, right? I hope you got this point.